check on those slides here. Jim is an engineer up at Music Hall Studios in Columbus, as well as the OSU campus. And let's see what we got here.
Ohio State University.
Okay. We're probably on the microphone. They're there. Okay, machine. Okay, you all saw. I think I forget might be on the next. Yeah, we saw the next one.
It's probably just not. You don't have to come to what you're doing. It's something that's playing better.
I think else is like 50. Yes.
You usually don't. You don't need it.
As people run that movie, there should be a pointer right here. That's just Disney movies I want. Yeah. Okay. So, we started recording this morning. Off to a kind of a rough start. We had some problems with one of the bands, but a brilliant local artist decided to fill in Studio B. So, no problem.
How do you wait then?
Yes. Anyway, we'll get started then with Jim. Okay, the floor is yours. Thank you.
Make sure to put that.
Okay, I just got in, so I'm a little frazzled right now. I drove down from Columbus. Kind of hot out there, actually.
Yeah.
Glad you're inside. As you said, I'm going to talk about the creative use of Outboard here. This first section will be about the technical end. The reason being, you really kind of have to have a grasp and understanding of what is happening inside that box before you can really figure out how you can use it. I know I've tried it from the other end. I didn't know how to use some of these devices before I tried to use them. And it's just like spend a lot of time playing around before you get anything that's worth listening to. So I think if you understand the basic concepts that are involved, what you're after, what the device is capable of doing technically, without getting into all the circuits and so forth of it, but just a basic understanding of it, I think you'll end up having a lot better control over the type of effects you're going after. Basically, effects are, or signal processing of any sort is used for a specific purpose. And now normally you do not use the effects that I'm going to talk about in the actual recording procedure. I don't know, have you guys laid tracks, rhythm tracks, things like that yet?
No.
Yes, no, maybe. Okay, well, essentially in your session, the first thing you're going to go and more than likely is going to lay down the rhythm tracks. Just record the basic rhythm, and then you're going to overdub vocals, synthesizers, whatever. But essentially you're going for the best signal noise on the track that you can get. The effects that I'm talking about more than likely will be used in the mix down process. In other words, when you've got all the tracks down and then you go and mix the whole thing together into the 2-track mix down, you're going to want to add certain effects to make sounds go all over the stereo image, from left to right or whatever, or maybe delays, things like that. This is all done in the mix down. It is not done as you're recording the tracks, with one exception, and that would be sometimes you'll use compression, which I'll get more into in the actual recording procedure. But I think with that one exception, almost all of these would be used in the mixdown. The first, well, let me start at the beginning. One of the things that is most predominant in modern multi-track recording is the use of echo and reverberation. Two terms which kind of have nebulous definitions. Most people aren't real. And the reason being is that they are both very similar. First of all, this room itself has reverberant characteristics to it by virtue of its size, the type of material that the walls are made of, and so forth. The effect you people have on this room right now is to deaden the high end of my voice and the sounds that we're hearing in here. Just by virtue of you being here, you're absorbing some high end. And if you were all to leave all of a sudden, which you may do eventually, but if you were to leave, the high end characteristics of this room would increase by virtue of the fact that you're no longer absorbing as much. Okay, so the room itself, you record in. When you put up these microphones to record whatever you're recording, the drums, the guitar, it has some effect on the characteristics of the sound you're going to achieve. No matter how close that mic is to the instrument, there's going to be some effect of the room on the instrument. And of course, on the bleed into the other microphones that you get of the instrument, it's going to have to do with the room characteristics. If you have this is a reasonably dead room. There are some live surfaces. In other words, the wood and the plaster serve to reflect a little bit, but the carpet absorbs a lot. Okay, so I would say the reverberation here is pretty light. It's not strongly reverberant. In other words, you don't hear most of what you're hearing of my voice is the direct sound. And there are other sounds that are combining to add and reinforce my voice or any other sound that happens in here. Somebody coughs or sneezes. It's by virtue of it reflecting off the various surfaces around the wood and even the carpet to a certain extent. That all these signals, if you want to call them that, will add together and they form the total sound that you hear of my voice. Now, the one thing that determines there's a difference between the two things which I was talking about, which is echo and reverb, or reverberation. Only in technical journals where you read about reverberation. In other words, usually they just leave that out and call it reverb, just for shortening it by 2 syllables, makes it quicker to say, I guess. But essentially, like I said, these two words mean a lot of the same thing, but the echo refers to, okay, you have the direct sound. Let me give you an example. If you're talking about in a concert hall, I know you're going to have trouble seeing this, so I'll turn every once in a while so that you can. Let's say there's a room here. And I'm up here on the stage. And there's people out there. Okay? When I talk, and there's somebody listening right here, there's going to be sound traveling directly to that person. Even if I turn this way, there's some sounds going directly towards the person. It's referred to as the direct sound. And that's a portion of what this person will hear. What this person will also hear is what is reflected off of various surfaces and then reaches his ear. And say this is off the ceiling, this is off the floor. And let's say this one going back here is the back wall back here. It's hitting that and reflecting the person, okay? So he's receiving all sorts of signals at the listening point here. They all are my voice or the speaker's voice, but they have different characteristics to them because of the delay as a result of the difference in distance. In other words, this most direct sound is getting here the quickest. The one that's reflecting off of here and coming down is getting there, a longer delay in this reflection. So as a result, the sound is getting there later. And all these will add up. And if they're closely spaced, and there are none that are pronounced, none of these reflections are real pronounced, they form a reverberant field, a reverberation. In other words, if they hit, here I'll graph here. This is the initial attack right here. See, I just scream and stop. This is the initial attack, and there's going to be reflection signals that are going to reach the ear that are these as a result of these reflections. And they'll have various amplitudes, and they'll start becoming closer and closer to space until they start to get real close, and they're just kind of mud down there. All right. Well, if this first reflection, this is time, this direction, this is amplitude up here. If this first reflection is very strong and there's a significant amount of delay between the direct sound and when this first reflection gets here via this path, it will be perceived as an echo. In other words, it will be a distinct sound. You've heard it like in a canyon. If you go into a canyon and you say something, you go, hello, and it comes up, hello. That's an echo, okay? That's the obvious part. The reverberation is essentially the same thing, but what it is these are not nearly as strong. These what would be echoes, if there's long enough time delay, enough amplitude, start to muddy together, and they just are happening at such a rapid rate that they're all reflecting to this person, that they are perceived in a group, and none of them become distinct. They just become sort of an extension of the sound, you know, the initial scream or whatever it happened to be here. So, does that make any sense to you as the difference between echo and reverberation? Because that's fairly important. It will become extremely obvious once you start dealing with these things in the studio, the difference between the two. But initially, it's kind of hard to have two words that essentially mean the same thing, and there'll even be more of those. Another concept that I mentioned was delay. Okay, that's a pretty obvious concept. It means, you know, a length of time between one event and another event. Okay, and the delay I was talking about was the delay between those reflections reaching the person's ear. In other words, that was the delay between the initial signal and the reflections off of the wall when they were coming to the person. This was the delay. It's usually measured in milliseconds, which are thousandths of a second. Okay, that's how we'll be dealing with most of these. I don't think you'll get into too much any shorter than, well, sometimes you'll deal in microseconds, but most of the time you're talking about milliseconds. Another thing is that the decay of this signal, I should have left it up here, is how long it takes for this in a reverberant field for the total signal to die away. In other words, how long would it take my voice to die in that way in this room? As I said, it's not a very reverberant room. It dies away pretty quick. But if you were in a concert hall, I'm sure you've all gone into an empty gymnasium or a concert hall or something like that and talked, and it takes a long time for your voice to die away. Well, that's called the decay. Essentially, it's the time it takes for the signal to decrease by 60 dB from the initial, you know, the initial amplitude of the signal. Okay? In other words, the time it takes it to go down by 60 dB. So essentially, at that point, it's no longer distinguishable to your ear. If you had a real sensitive sound pressure gauge, sound pressure level meter, it would probably register something there, but you wouldn't really detect it with your ears. So those are essentially the four concepts we needed to know to talk about reverb and echo. As I said, it's probably one of the most common effects. You'll hear it in just about any music that you listen to. And there are a variety of ways of achieving it. First of all, you can, you know, live recordings, often it's achieved by virtue of mic placement to pick up some of the natural room reverberation. And it's obviously, in a good hall, the best way to go because you achieve a more natural sound in it. It kind of blends the whole sound together. But often, you're not in a live situation, as you are here, not in the studio, you do not have the natural reverberation in the room. The studios are designed to decrease that reverberation so that you can get isolation between instruments that are relatively close together. Because if there's a lot of reverberation, you have this mishmash of signal. There'd be no way you could get an isolation of a drum sound or a guitar sound. It'd be too loud and everything would be crossing over and you wouldn't be able to deal with the tracks separately. So the studios are designed to have very little reverberation in them, and then you have to add it in some way to give more of a natural or a pleasing sound to the instrument, whatever it may be. Now, those four concepts we talked about, echo, reverb, delay, and decay, they all come into play when you are trying to recreate the natural room ambience. The first would be, of course, you have to deal with the delay characteristics. In other words, there was some difference in time between when you hear the first sound and the reverberation itself and the decay. Those have to be recreated. And this delay is recreated in a number of ways. The most common, there are essentially three. There's a tape machine delay. Digital delay. Abbreviated DDL. You've probably seen that in a lot of trade magazines. What the hell is that? But that's what DDL is, digital delay. With analog delay, and these two are very similar the way they're achieved. And the fourth and a real obscure one is to acoustic delay. And I'll get into why it's obscure and why it's hardly used at all. First one was tape machine delay because that was the only way they had to delay a signal initially, was to use, you'd use the second tape machine, and what you do is you feed the signal. Okay, let's just assume this was the... You learned about tape heads yet? No.
Yes.
Yes? Okay, good. That'll make some sense then. Okay, let's say here is the record head, here's the playback head. You know that there's a distance between the two of them, okay? And in most instances, it's around 1.5, 2 inches, something like that. It's going to vary from machine to machine, but standard is in that range. And what you do is you feed the signal that you want to delay into the record head of the second machine. And then you take the output from the playback head and feed it back into your console. So here's the signal coming in. And what you do is you put this machine in record. So it records the signal here in the record head, and then you're sampling back off the playback head. The time differential here is the amount of delay you're going to get. And it's related directly to the tape speed, because if the tape goes faster past the heads, there's going to be less delay. All right. So, for example, they give in the book, in your textbook, with a 2-inch gap between the heads, that I think 30 IPS is, at 30 IPS you have around, there's a 256 milliseconds, I believe. And at 15, you have about 132. 7.5 would be half of that again, 6. So you can achieve these 3 or 4, depending on your machine. Most machines either combine these 2 speeds or these 2 speeds, so you're usually limited to just two choices. You either have 256 milliseconds of delay or 132, or the combination of 132 and 66. Problem with this is these are fixed times. Unless you have a vary speed or something on your deck, or you have some way of varying the speed of the deck, you are dealing with these 2 specific delays, and it just happens that neither one of them really that useful. The 132 is in many instances, but 66 is somewhere in the middle where it's useful for certain effects that if the tempo of the music is at a certain speed and you want to delay a signal. But it's hard to control. You have to keep rewinding the tape. And if it runs out halfway through the mix, you haven't been watching it. You're mixing along, you made all your punches right, and everything's going along real great. Delay, tape runs out. You gotta start all over. Also, you're subject to the electrical characteristics of the machine itself. In other words, you have to have a pretty high quality machine sitting there just being used as an acoustical delay line, and that's talking about $1,500, $2,000 worth of tape machine just sitting there as an acoustical delay line. It's not real cost effective. And it does have mechanical problems. If the heads get dirty somewhere during the session, and you don't clean it at the right time, you're going to have a muddy sounding delay. And also the characteristics of the machine itself, the high end, obviously it is going to be different at these various different tape speeds. If you have a signal that you're trying to delay, there's a lot of high end in it, it's going to be decreased if you have to run it. If you need a 66 millisecond delay, the high end is going to be decreased a little bit by virtue of the characteristics of the head. So as you can see, not exactly an ideal type of delay, but it's useful in a lot of situations. It has characteristics of it that some engineers kind of believe are more musical, in that it is another type of analog system. In other words, it's very much the same characteristics of the sound are the characteristics of the recording on a tape itself, because you're using a tape. Yeah.
In case we're using a tape machine for delay, would you be adding more noise?
Yeah, that's another point. You would be adding more noise. You're adding the noise that is increased by the use of the tape medium itself has a certain noise level involved in it. And that would be another factor that you would want to consider. So that can be used, but it has its points that you sort of will want to guard against. The next two types of delay devices that are the most common, you'll find in most studios, are the digital and analog delay. And they function very much alike in a lot of ways, in that what you do is you have talk on the floor. You have, call this your black box, okay? This is your delay and the signal coming out. Feed the signal in, and what it does, it's an analog delay line, and I believe you have one in Studio B, right? That by virtue of what's called a bucket brigade type of electrical circuit, I won't get into it too much. What it just kind of circulates the signal itself in analog form. In other words, in electrical form, the way it came into the delay through a bunch of circuitry, and it slows it down essentially. And you can adjust that by adjusting the different controls on the front. Their potentiometers is what they are, resistances that you adjust in order to slow down the signal. It doesn't alter the frequency characteristics, which is a good point of it. And essentially, in most units, you can adjust pretty precisely, from, say, about maybe 5 milliseconds to, 250, 300 milliseconds, somewhere in there. And those are most of your useful delays. Nice thing about it is you can be very accurate. If you find that for your specific purpose, you want 116 milliseconds, and as you remember the machine, you can only deliver 132 or 66 or 256 without a vari-speed control. So you can set this to exactly what you want. And it's useful in a lot of situations. So the analog delay is good. You'll find that in a lot of studios, and as I said, you have one here in Studio B to play with. Digital delay works a lot the same way. It has a control that you can adjust, and it basically goes through the same type of delay, although there are some that go even higher than that. You have what's called a memory. Essentially what it does is it stores the digital delay. I don't know if you're very familiar with digital electronics at all. You probably heard the word quite a bit. It's used in a lot of different ways, digital watches and so forth. This has nothing to do with digital watches. They're just talking about the readout on the watch is in the form of a digit, as opposed to hands going around. But the digital delay, the signal comes in, and it's encoded as an on-off pulse, or a 1 or a 0 in the jargon of digital people. There's no other way that the thing can be stored. It's either stored as a 1 or a 0, an on or an off. And the signal is sampled at approximately 50,000 times per second. It samples the value of the voltage coming into it, which is the signal, because the signal is constantly varying, and it just samples it at different parts. Say that's the signal, and it just samples it all over the place 50,000 times per second. Stores that on-off information, and by adding a memory or whatever, you can have it stored for a long time. I mean, most units will only go up to maybe 512 milliseconds, which is about half a second. but that's about as much use as you need in the studio. There's usually no need to store a signal any longer than that. Half second's pretty long. So the difference between analog and digital are essentially just the method of storing the information. They essentially do the same thing and are very adjustable. The digital delay that you have is in the form of a even kind harmonizer. I believe that's in Studio C. So you'll have the opportunity to work with that a little bit. Although that is not as versatile as many because it has certain fixed increments that you can adjust in. It's like, I think you can adjust everywhere from 7.5 milliseconds to about 112.5, which again is a very useful range. You won't often find that you even need to go over that. And if you do, you can add a tape machine in front of it or something like that. Again, you'd be increasing noise and decreasing signal quality a little bit. But both the analog and the digital delay have real good frequency response. They can essentially have the same frequency response as the DEC that you're using. So there's virtually no degradation in the sound quality that you're going to be getting through the machine. The last one is the acoustic delay. And I can only think of one example offhand, and that's the Cooper target tube, when they talk about that in your book. And it's not used a whole lot. It's not real versatile. Now, the ones I've been talking about are not subject at all to outside, shock or vibration, anything like that. They don't respond to that. They're electronic gear, just like the deck itself. I mean, if you kicked it over, it would make a difference. But as far as just little vibrations, sound in the room, it doesn't affect it. But the Cooper time cube is an acoustical delay line, and it's got to be pretty well physically isolated, or it will respond to sounds around it. Now, it's pretty well isolated in its own box anyway, but there's still little jarring that you can do to it that will cause it to pick up sounds from outside. And it's just an acoustical delay line. It's just like a big tube. And it's tuned, and it's got a certain length to it, and all so forth. And it provides, not even sure what the exact delays are, but they're less than, I'm sure they're less than 30 milliseconds. I think the 30 milliseconds total. There's two units, and I think one's like 17 and one's 14. Something like that. Is that 14 and 16? Yeah. So, God, you guys have been reading. So, as you can see, real short delay times, they're not real useful, other than for certain special effects that are useful. But again, you have isolation factor involved, and it's just not. There are with the advent of digital delays, just about could say goodbye to the Cooper company just decided they were going to go out of business. But nobody's buying them anymore. No, you might run into some in studios if you ever work at it eventually. Let's get on to one of the effects that can be achieved. We were talking about echo before, right? There's an effect that you can achieve, which is very similar to echo electronically, and it's called doubling. And essentially, that echo time differential between the first and between the initial sound itself and the first inflection, there's a certain time differential here, a certain delay, where these will be perceived as two discrete events, as opposed to sounding like the same thing that's kind of spread out. And it depends on what the signal is itself. But for most musical signals, somewhere in the range of between 20 and 40 milliseconds delay here. When you start increasing from 20 to 40, you end up at some point in between those two being able to tell that there are two discrete events as opposed to one. All right? And this can be used to double, for example, vocals. And you hear there's a lot of albums where they do that. Almost all rock music, they will double the vocals. And instead of having the person come in and sing the same thing over, having little phrasing differences, which will be noticed right away, and the person has to go over and do it until it's perfect, then you can just put in most cases with vocals, it's around a little bit less than that, maybe 10, 15 milliseconds delay between the two, pan one left and one right, and there's just enough difference that it sounds like two voices singing the same thing, and it's, of course, it's identical signal, but it's just delayed by this amount, by 10, 15 milliseconds, whatever they determine is the best sound. It'll vary with the speed of the music as to what will be perceived to be doubling or discrete events. And different types of instruments will have different attacks, like a real percussive instrument. Any drums or tambourine, something like that, it'll have a shorter delay in here between what would be considered a discrete event. In other words, it'll sound like pow pow instead of same drum hitting. There's a lot of doubling that goes on in records with that effect on drums. We'll get more into the actual uses in the second section, which is later on this afternoon. I brought in some tapes to demonstrate some of the effects, so I'm sure a lot of these are just kind of jumping around as terms right now, but we'll try and get more to the meat and potatoes of it at that time. Anyway, so there are ways of creating reverb, and we got to get into those. Talked about how we're going to create the delay, all right? And that, in many cases, is used in conjunction with the different types of reverberant devices. And I think you have a mic mix reverb in Studio C. I'm not sure what the other ones are, but they're all spring reverbs. So I'll talk about those first. There's essentially about 3 or 4 different types of reverb units. One which isn't in your book, and I have tape demonstrate it so that you can all hear it. You may have heard about it in some of the trade magazines, like it's advertised an awful lot in modern recording. It's called the Ursa Major Space Station. I thought that, I kind of laughed when I first heard about it, but I heard it in person at the AES show in New York last November, and I was pretty impressed with it. So I brought a tape of it, their demonstration tape of it, so that you could have the advantage of seeing what it can do. Because one of the things they mention in your book is that through the use of delays, it's possible to create a reverberant type effect, because that's all you have, is you're having various space delays at various amplitudes create the overall picture, which is reverberation, right? The various delays between these. And if you adjust delay units right and have maybe a couple of them being driven by the same initial signal, set of different delays, you combine all the signals together, you can get a pattern similar to this. Most of them sound real faked. Most of them don't sound like real room reverberation. These are too distinct, and they aren't randomly enough spaced to sound like it's in a real room. They're too rigidly controlled. The Ursa Major Space Station, they've managed to, with advances they made in digital electronics, they've managed to be able to work out some of this problem. This is a pretty realistic sounding unit, and we'll get to that later. Spring reverb, most common one, and I'm sure if any of you are guitar players, you have one in your guitar, whether you know it or not. It's called reverb, and whenever you kick your amp or something like that, it makes a real loud crashy noise and springs around for a while. Well, it's just a spring. That's what it is. It's got well, it's a real rough idea, but somewhere along it, and it's designed according to the spring characteristics and the company's budget and so forth. But they will have some sort of an element that will transduce the signal that you send in that you want to have sound reverberant on this spring, and then somewhere, and in most cases, if the stereo type of unit, there will be either 1 or 2 transducers. They may have 2 springs, they may have 1. Anyway, these are where the sound is picked up at different places on the spring. You get a slight delay because it takes longer for the sound to get to here than it does for it to get to here. It's the same sound because you have the same signal feeding it. There's a slight delay, and you add this to your mix left and right, and you get a slight delay, the type of delay that you get in a room, because everything doesn't hit you all at once. You get reverberation coming at you, some sort of a random motion by virtue of the size of the room and the way the room is. And that's what they try to reproduce with spring reverb. Problems with it are, well, there's quite a few. It's nice and inexpensive. You get real cheap ones in the guitar amps, and you can get good quality spring reverbs like AKG makes one. It's a real good quality spring reverb, although they had a lot of trouble with the design. But when you get one that works, it's real nice. And they've developed special isolation techniques and special ways of damping it so that the decay is adjusted in certain ways so that you get a real natural sound. But most of them have some problems inherent in the fact that they are a spring. First of all, for certain types of instruments that you're trying to add reverberance to, like drums. I keep bringing that up. I'm a drummer, but I also know the problems with trying to get a reverberant sound on drums. They have real percussive attack, real hard, especially a snare drum. And it just shakes these things all over the place. And so if you add a little bit too much snare drum, certain frequencies of the snare drum will cause the thing to set up and it'll just sit there and be real rigid, and then it won't vibrate at all. So you have to, when you're working with the spring reverb, essentially what you'll be doing is you'll be feeding the signal in. This will be coming back to your mixing console. And you'll have, these two inputs that will be left and right. And you'll adjust your faders to a certain point to get a balance. There's also going to be equalization, which we'll talk about, in order to make the spring sound the best. In other words, to try and remove or at least decrease the frequencies that give you trouble with the spring because it is a spring. You can adjust your equalization to make it more useful. And I think I'll get into that when we talk about equalization instead of right now. But essentially, that's a spring reverb. Plate reverb is, if I'm going too fast or slow, or you want to ask a question, just let me know. But don't sit there and yawn. Let me know what's wrong before, I don't want to bore anybody with what. Yeah, go ahead.
Are the Tapco units spring reverb?
Yeah. Anything that's going to be in a small container, we can just assume for the moment that it's a spring reverb. Because plate reverbs, which is what I'm about to talk to, are usually very large. There's a couple. Was there another question? There's a couple that are most common. The EMT. Actually, the EMT is the most common, but it's rather expensive. The other kind are the kind like the studio that I work at, where we built our own. We decided we weren't going to spend the several $1,000s that was necessary to purchase an EMT. And we decided we could make one ourselves out of rolled steel, and it works real well. It took us a while to get a lot of the bugs out of it. And it rusts. The EMT doesn't rust, so there are problems. You have to clean the contacts of them fairly reasonable intervals. You have to take care of the thing. You can't just let it sit down in there in the basement and go to pot. But essentially what it is, it's a plate that's suspended in a frame like that, somewhat like that. And it's going to have some sort of a transducer to transduce the signal, the input signal, right here, to the sheet itself. Just a big sheet of rolled steel, about 1/8 inch, 1/4 inch thick, most. Probably about an eighth of an inch. Depends on the material you're using, but ours is about 1/8 of an inch. And it's roughly 6 feet long and about 4 feet high. So it is fairly large. Whereas most spring reverb units will fit in a rack, a 19-inch wide rack, and it'll be about 19 inches deep and about 4 or 5 inches high. So the comparison in size is quite a bit. What you do is you have this, you're feeding your input again to one point. In other words, you have a mono input, and you take your output off of 2 different points. And it's up to you whether you pan them left or right, but I'll just do that for sake of explanation here. These two distances are not equal. In other words, the distance between here and here and here and here are not equal. The reason, again, to create the sense of time delay that results in giving you a kind of a stereo image. You can use that to create a stereo picture out of a mono signal. In other words, if you were just doing a straight 2-track stereo recording and one of your signal, like in a concert situation, say a violin concert or a piano concert, something like that, and you had standard 2 microphone technique or something like that, one of your sides crapped out, you can take it into the studio, put a little delay, send it over the right, and it'll give the impression of a stereo picture. It won't sound the same. It'll give the impression just by virtue of the delay between the two, because that's what you're hearing at your ears, is the delay. It sounds, and that's what's giving you the idea of a stereo image. So you can do that, and again, that's what gives you your stereo image with your reverberation unit, is having these two pickups at different distances from the source. There's little phase cancellations and so forth that result in sounding like stereo. Yeah.
You can't control the plate, right? You can't control the distance.
Well, you can't vary it as you're working with it, right? But you have to set it up in a certain manner so that you have the sound that you want. In other words, you can set up your plate and adjust the pickups until you get the sound that you want to have with the plate. And that's essentially what AKG does with their units. You know, they have someone travel with the unit to where it's going to be installed, and they adjust the pickups to where they need to be. But it's not continuously variable. In other words, you can't do it as you're mixing or something like that. It's just adjusted for an optimum position and left that way. One of the problems with any reverberation system is that this plate has got to be in an isolated area. Can't have it sitting behind the speakers or something like that, because it's going to pick up all of the vibration, then it's just going to be clanging around all over the place. So it's got, again, those are some of the problems that you have with a plate reverb. It gives a real nice true sound, because once the signal has stopped, okay, if you give it a, okay, the signal comes in, the signal stops. Okay, the plate doesn't all just rigidly stop. It just vibrates less and less and finally dies away. Gives the natural decay that you're looking for. Remember, there are a couple things you need: is the delay and the decay. Spring has a decay; it stops gradually from the signal, same as the plate does. It gradually stops vibrating once the signal has been removed from it, and that results in a decay that gives a natural reverberation. But this unit has to be in a very isolated place, or you're going to run into problems. So if you imagine, you got to set a whole room aside for this thing and isolate it. You got to spend some money acoustically isolating that room from vibrations, trucks going by or whatever. Fairly expensive proposition. The spring reverb is a lot less expensive, just in the fact that you don't have to isolate it nearly so much. Yeah.
That transducer looks like a speaker.
Yeah, it's very similar to idea, right? Moving coil type of mechanism. It's like a speaker. Yeah. Anything else? Okay. The last and most expensive is what everybody wants to have but can't afford. And that's the acoustical chamber. And it will quickly become obvious why most people can't afford it. And that's because it's essentially what I'm just saying. It's a chamber, a room that you've got to set aside, a large room that you've got to set aside from your recording complex and isolate, spend a lot of money isolating it. You've got to have speakers and microphones in it as your transducers, your input and your output. And you're talking about a lot of dollars involved, especially with real estate being what it is. It's hard to set aside an entire room just so you can have a nice reverberation tune. However, it does give the best sound. It definitely gives the best overall sound. When it's designed and treated properly, it gives the best overall acoustic sound. But essentially, it is just a room. There's a picture of one in your book, which might give you a better example, but I'll just try and briefly draw it here. Essentially, you have a speaker somewhere in here, and it's aimed in a certain direction. Most of these corners will be sort of convex. In other words, they'll be turned in like this, as opposed to out or square. And it causes the sound to reflect around a lot more for a given small area. The idea is to optimize the difference between the size of the room and the amount of reflection you can get to recreate a natural environment. Essentially, though, the room is going to be extremely reverberant. It'd be like walking into a gymnasium or something. it's virtually unusable just to sit there and listen to something in. But it's extremely usable as sending a signal into it and bringing back a little bit of it to add, give an overall reverberant sound to whatever you're mixing down. Essentially, the sound comes shooting out of the speaker, bounces around, and you have a microphone somewhere. And that goes back and feeds into your console. So in other words, the signal comes in here, and the output is here. And in order to recreate stereo reverberation, you would have, you know, 2 microphones spaced at a certain distance that you had set up and judged to be the type of sound you want. There, so you have left and right output.